Hi folks, Mr. Long here, screencast number 3 for Calculus Rules Mastery Testing, and this is going to be all about the chain rule. Okay, so, and I didn't write down the general chain rule, which I probably should do. So the general chain rule is dy by dx equals dy by du, du by dx. And again, you can rearrange that as du by dx times by dy by dx. The whole idea that the du's divide out and you end up with dy by dx. Dy by du in our case is the outside function. Du by dx is the inside function. So the outside derivative multiplied by the inside derivative, or inside times outside, which is typically the way we do it. So how do we decide on inside and outside functions? Well, let's take a look at our first function that we're going to differentiate, which is our tangent slope function. We have to look at the innermost set of brackets, there and there. And that will establish our inner function, which is u in this case. Then in this case, there are no more brackets except for the, oh, by the way, something important here. The outside set of brackets using the d by dx notation just shows you where the function is that you want to differentiate. That doesn't relate to the chain rule. That set of brackets just says differentiate everything inside that bracket. Okay, so you can see if a function just has one set of brackets, then like this one does, there and there, you're just going to have a chain rule with y and u. Okay, so one set of brackets equals, and remember, a square root symbol, by the way, is just like a set of brackets in terms of being a grouping symbol. Okay, so there's u. U is the inside function, which is 4 minus 5x. Then what I would do is consider that u, and what have I got? 3 multiplied by the yellow to the exponent of 7, right? Or 3u to the 7th. So let's go ahead and do that. So here's the inner function, 4 minus 5x, and here's the outside function, 3u to the 7th. Now we need to do our derivatives. Du by dx is simply negative 5. By the way, this is a simple case of the chain rule. Then we've got our y value, then I do dy by du. And 3 times 7 is 21, right, for this one here. And then I ended up with, I reduced the exponent by 1, it's u to the 6th. Now I multiply things together. Du by dx, the inside derivative, multiplied by dy by du, the outside derivative. And one of the key things that we do here is I always look at the coefficients or the constants and I multiply them together first. So negative 5 times 21 gives us the negative 105. And then I've got, the only thing that I have left after that is actually the u to the 6th. And u is worth 4 minus 5x. So it's 4 minus 5x to the 6th. And you're done. Okay, that's like a level 2. If that's the only type of chain rule that you would be able to achieve, then you'd be looking at a level 2 in the chain rule derivative rules. Okay, so that's, and again, pause, rewind, go over that. That's the simple chain rule. Let's look at a medium chain rule question. Okay, a medium chain rule question. And see how we do on that one. So here it is. So again, these brackets, the outside brackets, denote the boundaries of what you're going to differentiate. So that doesn't tell you anything about the chain rule. It just says whatever's inside that set of brackets. Now, we did say that a square root symbol, for example, is really just like a bracket, right? So it tells you where you need to do the calculations first. So having one root symbol, in this case a cube root symbol, that's like one set of brackets. Remember, if we have one set of brackets, we apply the chain rule in it's just going to have u and y. Okay, so first thing we notice is that we're going to do, so I've got 6 over the cube root of something, which I'm going to rewrite as 6 multiplied by something to the negative 1/3, right? And actually, that's good because I've already done these calculations, and I believe I made a mistake here. So this is good. We're going to go through this and do our corrections as we go. Okay, so u will be the thing that's inside, that's the innermost thing. Remember those brackets right there represent the boundaries of the derivative. So the u is x cubed plus 4x right there. And then I do the derivative du by dx, which is going to be 3x squared plus 4 right there. Okay, on the other side, I've got 6 multiplied by u to the, it should be negative 1/3. Okay, negative 1/3. So that's going to make this interesting. So it's negative 1/3 minus 3/3. So it's actually, I need to correct that. That's going to be negative 4/3. Okay, negative 4/3. And again, I have negative 1/3 multiplied by that 6. So that should have been negative 1/3 multiplied by 6, which works out to negative 2. And it should have been u to the 4th, okay, cube root. Okay, because it's negative 4/3. The 3 denotes the cube root. The negative 4 is the exponent, so I bring things to the bottom. Okay, and now I have to multiply this out. Okay, so what I'm multiplying is this du by dx multiplied by dy by du, which is right there. Okay, so first thing I always do, multiply the coefficients. Well, what are the coefficients for that? Well, really, it's just 1 multiplied by that bracket, so it's a 1. Okay, and then the other one is the negative 2, so it's negative 2 times 1, which would give us negative 2. And then I'm multiplying by that right there, the 3x squared plus 4. That's good. And then the last thing I have to consider is this right here. Okay, the cube root of u to the 4th in the denominator. Okay, and u is worth x cubed plus 4x. The cube root is right there, and that should be to the exponent of 4. Okay, folks, so again, if you want to go over that, pause, rewind, but copy down the original question, copy down the final answer, and see if you can get there. All right, the triple chain rule. So if we look at this one, I'm going to put in black. The black part is going to denote the boundaries of where we're doing the derivative. That doesn't have, again, anything to do with the chain rule. But let's take a look and see how many sets of brackets we have. So there's a set of brackets right there. That's the innermost bracket. And then another set of brackets there and there. So that means I've got an innermost function right there of u. The next set of brackets denotes the next function going out, which is v. And then the final function is y, because that's where the function starts and ends. Okay, again, start from the inside and work out and look at every function is defined by a set of brackets or a square or cube root symbol, or root symbol, radical symbol. So now we have, it's called a 3-layer chain rule. So the most inner function is u squared plus 3 right here. And that's a pretty easy derivative to get, 2x. Next I move to v. V is defined as that 3 plus 4 multiplied by u, all to the exponent of 8. Okay, 3 plus 4, u to the 8th. The derivative of that is 8 times 4 is 32. Times by u to the 7th, and that's dv by du. Finally, I go to the most outside function. The most outside function is 6 multiplied by v, all to the exponent of 10. Okay, so it's 6v to the 10th right there. So again, do the power rule, 60 times by 6. 10 multiplied by 6 is 60, v to the 9th. Now this one definitely required a calculator. So how do we want to do this? Well, once again, what we want to do is go through and check our coefficients first. 2 multiplied by 32 multiplied by 60. Altogether, that works out to 3,840. After that, I've got an x. Check. I've got my x. And then I have u to the 7th. Well, u is worth x squared plus 3. So that's how I get x squared plus 3 to the 7th. Finally, it's v to the 9th. Well, v is worth 3 plus 4 bracket x squared plus 3 to the 8th. And then that's all to the exponent of 9. Okay, and I'm done. Square roots work the same way. I'm going to attach the solution sets right here, because here's the second triple chain rule one I did. And again, it has 2 sets of square root symbols instead of brackets, but it still works the same way. Okay, so that's another triple chain rule question. All right, so that's the chain rule in a variety of forms. And again, redo. There's 3 questions there. I would make sure you can do all 3 independently before you start to move on and do some practice. All right, have a good night or day.